We will now look at how we can streamline the knowledge graph construction and with a facade. So we're going to look at the SPARQL Anything project. And to do so, I welcome Enrico Daga, who's Senior Research Fellow at the Open University. Good afternoon, Enrico.
Good afternoon.
And welcome. So we're all ears.
And I can't hear you now. I think something's not working properly. Can you hear me?
Yes, we can. Absolutely. We hear you and we see
so
you. So go ahead. Yes.
At some point, I couldn't hear you anymore. OK, so I'll go ahead. So thank you. I'm Enrico Daga from the Open University. And I'm very happy to be here today to talk about our SPARQL Anything project that is about the knowledge graph construction. And knowledge graph construction is an important problem. It's an important problem because knowledge graph is essentially today the main application for data integration, the main solution for data integration. And its almost main raison d'etre is to support a seamless integration of a lot of data. However, there is a lot of work still to be done that hampers kind of the effectiveness of building knowledge graph. Particularly, we focus today on the syntactic heterogeneity. There is a huge amount of different formats, and usually developers have to do, and knowledge graph engineers have to do a lot of work to integrate them. So in particular, what I'm talking about is happened in the context of two European projects related to cultural heritage. And this is particularly an interesting domain area for knowledge graph and data integration because this is a sector where there is a huge variety of type of assets. And this is reflected also on the formats and the problems that the knowledge graph engineer needs to solve to integrate and build knowledge graphs. So if you look at the literature, there are a wide set of approaches for querying and integrating data into RDF. We go from direct mapping approaches that are format specific, so like TARCL that is about querying tabular data, and CSV to RDF, JSON to RDF, and so forth. There are mapping languages. We heard about RML in the previous presentation that comes from R2RML, that was a configuration language for databases. But this is required essentially the knowledge graph engineer to learn a new language. And usually they are applicable to a set of popular formats and are quite difficult to extend outside those very popular formats. And there are some approaches that use SPARQL, but they customize it. They change it significantly. This is kind of the approach taken by SPARQL Generate. This is one of the examples on the right. And these are also quite demanding as they have a quite steep learning curve and require users to learn different things. They need to learn JSON path, X path, and then find a way to and understand how to embed these constructs into the SPARQL query. So the main design issue, in our opinion, is that all these solutions transfer the complexity of the data source to the user. So the user needs to know RDF, needs to know SPARQL, needs to know also all the specificity of the formats and use specific languages in their code. So this is very complicated in the end, using state-of-the-art approaches. And the main problem is that source can be anything. So clearly they can be CSV, JSON, XML, these are typical format. But in our project, this has been extended significantly. We have found that we needed to integrate data from Bibtex files, to query Markdown files, documentation files, to build knowledge graphs for competency questions, for example. We need to query web APIs, spreadsheets, and even musical scores in a quite complex XML structure. So we started to think about this in terms of knowledge engineering. So instead of saying, okay, this is a software engineering thing, this is something that we leave developers do, instead we say, okay, no, the knowledge engineer can actually approach this problem and can do it in its own way. So we started to think, what are the knowledge components that are common to all these formats? And we identified a few of them. We identified collections, containment, we identified sequencing and key values. No? And we make the bet that with a restriction of RDF, by selecting a small component, we can imagine and design a facade, which is a version of RDF that we can use to re-engineer potentially any format. And this is what we call FaçadeX, and this is the main approach of a new tool for supporting knowledge graph engineers in building knowledge graphs and querying heterogeneous sources as if they are already in RDF. And this is a very simplified example of how the tool works. So we overload, let's say, the service clause so that we can query resources that are not RDF. And through the facade, we can, with the knowledge graph engineer, can interrogate the data as if it is already in RDF. And we produced the tool is an open source project. There is a command line server version. One can extend it or embed it in application through a Java API. And even recently, we released a Python bridge so that one can use Python and the triplify data on the fly in the scripts. So this is one example that's a bit more elaborated than the one before. The nice thing of this is that this is compositional, so you can compose different service clauses. And in this example, we query a CSV file, we find the file names of JSON files, we query the JSON files, and we extract subject topics from each one of them and build a SCOS taxonomy from these various topics of artworks in the Tate Gallery Open Data. And this is another extreme case where we studied how we can extract musical features to support music information retrieval tasks, for example, melodies and grams, and populate an ontology that represents the musical score. So this is the documentation page of the project, and the tool is quite rich of functionalities. Suppose a nice variety of formats. We can query HTML, Excel, you can query Markdown files, YAML. You can connect to web APIs through an HTTP client. All of this within the SPARQL query and in plain SPARQL 1.1. So that without the need to learn an extension of SPARQL or to learn a different language. And the documentation also includes details about format-specific options for the various formats and a nice set of tutorials from very basics to more complicated one. So, in summary, what are the benefits of this approach? So we allow to transform and query resources with heterogeneous formats directly in SPARQL 1.1. So there is a quite low learning demands for knowledge graph practitioners. They don't need to know to learn about JSON, JSON path, XPath, etc. They can just focus on learning the facade and how you can, with that, explore a variety of data formats. There is a single consistent abstraction for potentially any data format. We actually studied this theoretically, and we demonstrated that FaçadeX can be used to express any format that can be represented as a BNF grammar, which is quite a powerful statement. And clearly, the fact that we can use SPARQL to query anything means that we can also generate anything that can be generated with SPARQL. We can generate RDF, RDF star, and as well as tabular data. Often I use SPARQL Anything to query CSVs and generate other CSVs. And that's perfectly doable and quite handy, frankly. Challenges. So now the current phase of the project is focused on trying to study ways of executing and running these SPARQL queries. The current reference implementation use a view materialization approach. So essentially the source data is triplified in memory and the query is executed in memory. We implemented alternative approaches, for example, one based on slicing the source. In the case the source file is very, very large and we want to have kind of memory restrictions and constraints. then we can use this slicing approach to segment the file and only query windows of the content in memory. But there are other strategies that can be implemented, for example, full-fledged query rewriting, and then and learn a bit, studying a bit more on how, for example, federated queries and SPARQL optimization can be applied to improve the memory requirements. And also, we want to develop more tools to support users in exploring the data through the façade. At the moment, the tool is based on SPARQL. You need to write a SPARQL query, but maybe there is a space to explore how the concept of façade can be used to develop user interfaces that are intuitive to explore a variety of content formats through the lens of RDF. Extending the tool to new formats. Of course, every time we have a nice issue tracker, so please go there and propose us esoteric formats to support in our tool. And our bet is that they can be represented using our approach based on the façade. And there are a lot of features that we are considering, and we are looking towards extending the development community. So it's an open source project. So if anybody can join and help to develop features that they are interested into. And finally, we want to also start extending the capabilities of the tool so that apart from doing SPARQL queries, also we can probably generate things that are beyond SPARQL, for example, embedding a template engine and generate other form of representations. Okay, these are the credits time. So I thank all these people mentioned in these slides that contributed in different ways during the past few years. And thank you. I'm happy to answer any questions.
Thank you very much, Enrico, for being so perfectly on time. That gives us time to, or gives you time to answer the questions that we have received. The first question is, will this apply or will it be extended also to PDF? It is a kind of default document format in many environments.
Well, that's a nice question. I bet it is possible. I don't know the internal representation of PDF, but yeah, open an issue and we can discuss about it.
Very good. So something to bear in mind.
It will be an interesting experiment. We have done this with the DOCx, for example. So the current engine can query a Word file. Okay.
And is there a sandbox available?
Yes, there is a collection of tutorials. You mean, maybe they mean a web sandbox when they can try it. No, there is not such a tool yet. That's one of the things we need to work on. But following the tutorials, the very basic example is really simple to run. You need to download the command line jar and then execute it in a few steps. So I suggest you give it a go. Look at the documentation on the SPARQL Anything website. Look at the tutorials. There is a gentle introduction to SPARQL Anything. That's a 10 minutes read, and I think it will give you an idea of the potential of the tool.
Well, you've already actually started answering my next question, but maybe you can give us some more information, because somebody was asking you to elaborate a little further on the support offered to users and the benefits of the SPARQL Anything projects and what it can bring to users. So you've already started answering in terms of the support, but maybe you can elaborate a bit further?
Yeah, I mean, what we're trying to do is to follow a kind of open source an approach that is quite common in open source, just essentially building incremental documentation covering as much as possible existing useful use cases. So I really suggest to go to the documentation. And in terms of support, I think maybe I can elaborate a bit more on the potential, on what it can support in terms of connectivity. So there are quite a number of examples where we query web APIs, and we query also APIs, for example, for named entity recognition. So we have a nice SPARQL query where you can iterate on a CSV file, get labels, query Wikidata, or query DBpedia Spotlight to get entities, then use those entities to build a knowledge graph, all these within SPARQL. And there are other cases where you can use the command line of SPARQL Anything in a pipeline. So for example, you combine multiple queries, you run one after the other, and you can use the output on one query to parameterize another query after that. And there are quite a good number of extended examples. And the SPARQL Anything project on GitHub includes many repositories that are essentially showcases of the potentiality of the tools.
Thank you very much, Enrico. Thank you very much for joining us today and for being on time and to the point. Thanks very much. Bye-bye.